Okay, so as you recall in the last video, we used the copy monitor command to import the structural levels into our architectural file. So these right here are the levels. Alright, so by far we've got the TOS levels, but the thing is that the FFL levels are also needed. So along with the TOS levels, we're going to have to also draw the FFLs. Now we don't have the FFL levels in any other file that we could copy monitor from, so we're going to have to create them in this very file. According to the AutoCAD file, more specifically according to what we observed in the AutoCAD elevation right here, we figured that the FFLs, or the architectural levels, are 10 centimeters above the structural levels. For example, basement 2 is at elevation negative 10.5, and if we go over to the architectural file to check out its TOS level elevation, we can see it's negative 10.6. Okay, let's check out another one. Basement 1 is negative 7, and its TOS level elevation is negative 7.10. So basically the architectural levels are 10 centimeters above the structurals. So the first thing I'm going to do is I'm going to go over here, select level, then set it to pick lines, and I'm going to give it a 10 centimeter offset here so that when I pick these structural levels, their architectural levels will be created 10 centimeters above them. So let's begin drawing. I'll select this head, then I'm going to go ahead and click on to pick these structural levels and create their corresponding architecturals. Here we're going to have to delete L2 later, and as for the ground floor, we could use this default L1 level. So I'm going to continue lower, and also make sure you don't make the mistake of creating the levels for these foundational TOS levels. So here we've got one negative 10.5, and now I'm going to head over to AutoCAD to check the elevation value of the lower level. It's negative 14, so now we're going to have to go back to Revit and draw. I'm going to draw a level here. For example, let's say starting from this point all the way across to here. Now let's adjust its elevation. It's going to be negative 14. And thus we've drawn all of our architectural levels. Now the thing is that the drawing area seems a little crowded, the levels headers are overlapping each other, and just overall it doesn't have a very nice graphical look. So in these cases, we usually select one of the levels, then click on this little symbol here, so we could add elbows to the headers and be able to reposition the labels. So you might want to reorganize them like this. Or I could even bring this one a little bit higher so that it's closer to its level. Or some people like to move the upper header up and make them look like this. So this is another idea as to how you can reposition the labels to make their text look more coherent. Still, you're going to need to check and consider what your own project requires. Okay, so by far, these levels elevations are correct, only they've got the wrong names. So we're going to have to fix those, which we could easily click on these fields and rename them. Again, here you could apply any format you like. For example, I'm going to put FFL, followed by the elevation of the level, which is negative 10.5. And then I'm going to add the floor it is for. For example, this one right here is the second basement, so it goes basement 2. And there we go. So now I'm going to go through all the other levels, rename them, reorganize their headers, and we're going to come back and continue. Okay, so as you can see right here, I've renamed all the levels. And I've also reorganized them a bit so that the labels are clearer and easier to read. So as you can see, all the levels have been renamed, and for each floor we've got the 2 level pairs of FFL and TOS. Now the next thing we're going to have to do is to add all these levels to the floor subdiscipline, because we don't have these in the list there. So I'm going to go to the View tab, drop down Plan Views, then go to Floor Plan, and here we're going to be adding only the FFLs. Make sure you don't add the TOS levels as well. And so after selecting the FFL levels, we're going to click OK, and they will be added here. So at this point, we've got all of our architectural floor plans. As for the TOS levels, they've been copy monitored, and we could use them for drawing as well. Okay, so now we get to drawing the layered walls of the project, but first I'm going to tell you something. You see, in every project, when I try to draw anything, for example, let's say that maybe I want to draw the walls, place the doors and windows, curtain walls, etc., I would draw them for one level at a time, just like what we did for the structural parts. And the reason for that is if we attempt to draw everything on every level at the same time, then it would just be a repeated process over and over, and it wouldn't be worth to watch. Therefore, we're going to do everything for one level for now, and eventually I will show you the finished results. So for example, you will see how all the walls look like together. So we're just choosing to do everything for one level so we can learn all the tips and tricks, and to find out about some details or bugs that need to be fixed, and you'll be able to use the solutions on your own projects. So now as for the modeling of the architectural part of the project, you might remember that even for the structurals, we chose the ground floor. The reason is that this ground level contains pretty much all we need. It has stairs, ramps, escalators, partitions, curtain walls, and everything else, and we could proceed with most of the project by working on this ground floor. But there are also some other elements and tips that we need to work on, for which we might occasionally have to go over to some other levels to talk about. For example, for placing these plant elements over here in your plans, which we will get to in the plan drawing season, we might have to move over to this floor to discuss it. But for the most part, the things that we're modeling are in the ground floor. Okay, so now I'm going to go ahead and start with the walls for the project, but before that, let's talk a little bit about the walls. You see, we begin with the architectural modeling by drawing and placing the walls first. And right now in our architectural file, we've got all the levels we need ready along with their grids. So if I go over to any of these levels, I will find their grids as well. So we've got everything ready and set to begin with. Now you might wonder to yourself, why do we keep saying the hard and layered walls? We could just define a wall with multiple layers instead. For instance, if we go over and take a look in the AutoCAD file, actually we can see that this file is a two-phase and doesn't have any finished walls. But our standard sheet does mention that the finished walls need to be 3 centimeters thick, so we would just have to define a wall with those settings, with 2 finished walls on both of its sides, assign their materials, adjust their functions, and jump into drawing. So why do we even need the hard walls? So let's talk about it. You see, we never, and I stress that never, place one single wall to serve as the hard wall when we are modeling the architecturals for our projects in Revit. So in other words, it's not like we're going to be defining a single wall, then place the finished layers on both of its sides, and place multiple layers to make for one wall, and go on with the rest of the plan. So remember, we never do that in our projects, but instead we're going to be having one separate wall for the hard walls and a separate type for the finished walls. Now I'm going to show you why real quick, and we're going to move on. Now the reason is that the hard walls and the finished walls won't be scheduled separately, and another reason is that the hard walls will be beginning from the slabs, which would actually be the TOS levels, and then they go all the way up to the upper TOS. But the finished walls start from the finished floor levels all the way up to below the ceilings. So basically, even the elevations of these walls differ. So how could you just use one type of wall and place it in several layers and assign different elevations to it? Now you might think to yourself that you could just unlock the settings of the type of the wall in Edit Type and change its parameters values, including its elevation. That is possible, but it only works for one side of the wall. So like if you draw a multi-layer wall in your plan, for example, let's say I'm going to grab a basic wall here, I'm going to grab a generic wall, and then I'm going to duplicate it, and then I'm going to go over here to add 2 layers to it. I'm going to move this one down, let's add another layer, and then move this one down. Now let's say this one's function is finish 1, and we're going to make this one finish 2. Let's also give them some random thicknesses like 3 centimeters. Okay, so you might be thinking that you could just draw this wall and it should be fine. Let me disable thick lines. So you might be thinking that you could go to edit type and then you're going to unlock one of these finishes and be able to edit its elevation. So I repeat that would only apply to one side of the wall and not on both. Not to mention that doing so would also mess with the elevation of your wall, which is actually very crucial to your work. The fact that your hard walls are supposed to be starting from the TOS levels and the finished walls starting from the FFLs is actually something that you can never overlook. So remember, we never use multi-layer walls to make for the hard and the finished walls at the same time. So forget all about it, because we will have to define individual walls for each of them. And then we're going to also draw them individually. Now, I am going to show you how in version 2025 our work has become a little easier, because in the older versions this process of having to draw the walls separately was a little bit problematic, where we had to also put some time to join the hard and the finished walls together, and also cut the door holes in them. But the good news is that in version 2025 it all happens automatically. So case closed, we're going to be drawing the hard walls and the finished walls separate from each other. Alright? So now let's go ahead and draw the hard walls first, which we said we'll have to start from the TOS level. Okay, so in order to draw the hard walls for this ground floor, we're going to need to import its AutoCAD file first. But before I do that, I'm going to go back in here real quick, and I'm going to rename the ground level to its right name in the project browser palette, because it is still on its default name, so we're going to rename it to what we need. And now we can import the AutoCAD file. So I'm going to go over to the Insert tab, select Import CAD, then select and import the AutoCAD file. If you recall, I've already separated this in an individual file from the main one. Import unit meters, all settings are set, so click Open and the AutoCAD file will be imported. There we go. Now the first thing I'm going to do is I'm going to go over here and hide the scope boxes, the reference planes, and things like that, so that the file is less crowded and easier to manage. So this will be the result. Alright, so now I'm about to place the hard walls, but first there's something we need to check. You see, this type of wall we're about to draw has different thicknesses on different areas, or it might even have different materials, but how should we figure those out? The plan doesn't tell us anything. Like, if we go over to its AutoCAD file, right over here, we won't find any details that we need about the walls. All I can do is to just measure the distance of the wall and figure out its thickness to draw. But where can we find further details? For example, what if we need things like the material? You see, it's either your client tells you about the material of the walls, like they might want them to be of bricks or cement blocks or anything else. So you're either told directly or you're given a detail file by which you can figure out things like the wall's materials, or they'll just give you a finished sheet. For this project, we do have a finished sheet, which also includes the hard walls materials. I actually have it open over here. It's an Excel file, which, as you can see, it contains all the materials that need to be applied to all elements of walls, floors, ceilings, and ramps. So over here you can see that we've got the area name, like the lift or elevator lobby, the security room, garbage shooting, etc. And then over here we've got the material of the cornices used, for example, for the lift lobby. And we've also got the material for the hard wall of this same area. Now we're not going to focus on the rest. We will get to those when we get to the finishing. But for now we're only talking about the hard or base walls. As you can see here, we've got a scope that's named wall, which also contains some subgroups, like the hard wall or the basis, dimensions, insulations, and the final cover. That final cover is actually the finished wall, But our focus is on the base now. The base materials could be LECA cement blocks with height of 15 or 20, and then again LECA cement blocks in height 7 to 10, or we've got drywalls, brick walls, or glass partitions, also known as the curtain walls. Okay, so now let's check for the different areas to see which one of these materials are checked. Most of them appear to be of LECA cement blocks, and let's just ignore the glass partitions for now. We're going to get to the curtain walls later. But as for the other areas like the conference rooms, you can see that they have drywalls. Okay, so these areas materials, you can see that they're also divided by their levels. For example, we've got the basements, -1 and mid-floor, and we're actually working on the ground floor now. So we need to check the walls for the ground floor. In the ground floor, as you can see here, all of the hard or basic walls are actually of the LECA material. It goes for all of its areas. We've got a few of them on this level, which are all going to be of the LECA cement blocks. And as for their thicknesses, we're going to have to look into AutoCAD.